All right, 4-4 starts transformations, and this is a big and important section covered in college algebra. So through the guided notes, which I'm presuming you've looked through, done at least somewhat, there's kind of a lot of information. My hope is that I can try and summarize it for you as best I can. The easiest thing for me is to still kind of lecture this as I would in class, and then so you can sort of understand where everything comes from, and then summarize it. I think if I just try and summarize it without illustrating it, it doesn't really make any sense. I also don't feel that the Hawks does a very good job of motivating it, so that's what I'm going to do in this video. This is a quick motivation of all of the transformations. Now, transformations are going to be how we graph more complicated functions than just like our lines and our basic parabolas. The 4-3 common functions, library functions, that's what we're going to be using in this 4-4. So in order to illustrate, I'm just going to use the parabola because it's nice and easy and everyone's pretty comfortable with it. I'm going to do this a long way. So my x squared, my anchor points, we're going to use our -1, 0, 1. If I calculate f at those points, I get 1, 0, 1, right? So in, out. In went -1, out came 1, so the point I plot is -1, 1. In came 0, out went 0, so I plot 0, 0. In went 1, out came 1, so I plot 1, 1. Okay, so those are the points that I'm going to plot for my x squared. And in fact, I've done that. Now, I actually have to do a bunch of graphing, so I went ahead and graphed a whole bunch of these. But here's my parabola, just this black line. Now, if I am interested in graphing something other than just x squared, say I want to do, you know, x squared plus 2 instead. Well, so I set up my table. I'm still just going to do the same 3 points. -1, 0, 1. Okay, so -1, when I plug that into my function, that's -1 squared plus 2, which is 1 plus 2, which is 3. So in came -1, out came 3. Then I have 0 squared plus 2, which is 0 plus 2, which is 2. So in came 0, out came 2. And finally, 1 squared plus 2 is 1 plus 2, which is 3. So I plot 1, 3. So those are the points that would go on my graph. -1, 3, 0, 2, 1, 3. So -1, 3, so 1, 2, 3, 0, 2, 1, 3. So what's happened is if I started with these 3 points, this transformation, or how are they different? Well, the pink points are just the black points, but moved up exactly 2, right? 1, 2, 1, 2, 1, 2. Okay, so this is what we call a vertical shift. So the summary of this one is adding outside is a vertical shift. And what I mean by outside is that I squared it and then I added something. So I still got the 1, 0, 1, except that I added 2 to that. So the x's stayed the same, the y's I just added 2, right? So 1, 0, 1, 3, 2, 3. Okay, so that's what we call a vertical shift, and that's exactly what my picture is. Now the other kind of shift you could do would be a horizontal. So let's do x minus 2. Okay, so with this, I'm actually going to pick different x values, and I'm going to tell you why I picked them in a second. Okay, so I'm going to pick 1, 2, and 3. So I get 1 minus 2 squared is negative 1 squared, which is 1. So in went 1, out came 1. So I'm going to plot 1, 1. Then I have 2 minus 2 squared, which is 0 squared, is 0. So in came 2, out came 0. And then 3 minus 1, which is 1. 1 squared is 1. In came 3, out came 1. So the points I need to plot would be 1, 1, 2, 0, 3, 1. So 1, 1, 2, 0, 3, 1. And this is what we call a horizontal shift. So I've picked up my numbers and I've shifted them in the x direction. Okay, so why did I pick the points that I did? Again, this is an illustration. When we actually do transformations, we're not going to like be picking points. That's the whole reason we do transformations. Why did I pick the points I did? Well, my basic parabola has 3 points as the anchors, and I have 0 in the middle, right? Well, this is subtracting 2. So if I want to get back to 0, whatever I plug in has to be so that minus 2 gives me 0. So 2 minus 2 is 0, right? So I had to make all the points bigger so that when I subtracted 2, I was back where I would have started. So in this case, the y values aren't any different. I still have 1, 0, 1. It's the x values that have changed, 1, 2, and 3. So my summary is adding inside is a horizontal shift. And again, what I mean by inside is I mean I'm inside the squaring. I change the x and then I square it. So I pick an x, subtract 2, and then square it. And that's different from the other one where I squared and then did my adding or subtracting. Okay, let's do a stretch. Okay, so f of x is 2x squared. So this one I'm going to multiply. Okay. So f of x is 2x squared, graph x f of x. Okay, I'm going to pick negative 1, 0, 1 again. So what happens? I do 2 times something squared. So I square the thing, which gives me 1, and then I multiply. So what changed? Not my x's, just my y values. 0, so 2 times 0 squared is still 0. So in came 0, out came 0. Then I have 2 times 1 squared, which is 2 times 1 equals 2. So in went 1, out came 2. So again, the x values aren't different from my original parabola. It's the y values that have changed. Instead of 0, 1, 0, 0, 1, 0, I have 2, 0, 2. So that's what we call a vertical stretch. And stretch because you can kind of think of it as Gumby. You're just stretching it out. You're not moving it anywhere. You're just, you know, silly putty. All right. The last one is the reflection. Now I'm just going to do one reflection, but there are 2 different types of reflections. We'll look at that as we actually do examples. All right, so for this, I'm going to do negative x squared. So it's on, oh, I got to write a summary of the previous one. So my summary for this one I just did is multiply outside is a vertical stretch. Because you're multiplying things. Okay. So I'm going to pick the negative 1, 0, 1. So what happens? I have a negative on the outside of my x squared. So that means I do negative 1 squared, which is negative 1. So I still did the square. After I squared, then I hit it with a negative on the outside. So in went negative 1, out came negative 1. Negative 0 is 0, so this is still 0, 0. And then 1. So negative 1 squared. So the negative is on the outside. So I square. 1 squared is 1. Then I hit a negative, negative 1. So 1, negative 1. So the x's are the same, negative 1, 0, 1. The y's are opposite. Instead of 1, 0, 1, they're negative, 0, negative. So when I go to plot that, I'm still at 0, 0, but now I'm at negative 1 for my y value. Okay? So that's my reflection. So reflection, I can imagine putting a mirror along this x-axis, and this black function has reflected onto the pink function. Okay, so that's an illustration of the different transformations. Now, my summary is as follows. Maybe. There it is. Okay, here's my summary. If you add or subtract, then you have some sort of shift. If you multiply or divide, then it's some sort of stretch. If you have a multiply by a negative, that's some sort of reflection. If whatever operation you're doing happens inside of the function, you change your x's. If it happens outside of the function, then you change your y values. And that's exactly what we were showing with this. Here I changed my x's, so the subtraction was inside. Here I changed my y, so it was outside. Here I multiplied my y value, so it was outside. Same thing over here. I multiplied y, so it was outside. Okay, there is a specific order to the transformations. You have to do horizontal shifts, stretches, reflections, and then vertical shifts. Technically speaking, the order that you do these three in, I think, doesn't actually matter. But the vertical stretch has to be done last. Otherwise, you just work in, out. So work from the inside out. Make sure your vertical shifts are at the very, very end. Now, it might feel like this doesn't really make sense, but once we do some examples, once I do some examples and kind of walk you through it, I'm going to do a lot of examples. I think that this will make a lot more sense for you guys.